This video is on different types of graphs, so just conversion graphs, travel graphs, and then straight line or curved graphs, not things like bar charts. They'll be in the statistics video. So this conversion graph then, conversion graphs are used whenever you want to convert something. So it could be changing kilograms into pounds, or miles into kilometres, or pounds into euros. Anytime you want to convert something, you could use a conversion graph. So this one is to do with miles and kilometres, but the graph isn't actually drawn for you. They want you to draw it. So Sue knows that 8 kilometres is the same as 5 miles, and knowing just 1 point is actually enough for you to draw the whole graph, because it's just going to be a straight line graph. So 8 kilometres is the same as 5 miles, so go across to 8 kilometres at the bottom and up to 5 miles, and then that's what your graph would have as the point at the end. So then you can just join it back up with the 0 point, and that gets you your conversion graph. So just by knowing 1 point and joining it back up to 0, that gets you your graph. The conversion graphs will always be straight lines like this, and most of the time they go through 0, except there was one question at one stage that was to do with temperature and degrees Celsius and degrees Fahrenheit, and it didn't go through 0 because of the way those convert. So what you can use this for then, so it said plot this information on the grid to produce a conversion graph. We've done that. Then what they actually ask you for, it says use your graph to convert 4.6 miles into kilometres. So 4.6 miles into kilometres. So we go to where 4.6 miles is, so that's up the side. So 4.6 would be, there's 4, and it must be going 4.2, 4.4, 4.6, 4.8. So that would be 4.6 there. So you rule across from that point, so 2 wee squares below the 5, and you rule right the way across to your line. So go across to your line and then down, and it ends up being, the scale across the bottom works out the same, so it goes 7, 7.2, 7.4, 7.6, 7.8, so it's exactly between 7.2 and 7.4, so that would be 7.3 kilometres. Then part C says Sue has to travel 40 kilometres. How many miles is this? So 40 kilometres isn't on the map anywhere, or sorry, isn't on the grid anywhere. So there's loads of different ways that you could do this. You could use 4 kilometres, go up and over, and then times your answer by 10, because 4 times 10 gets you 40. Or you could go up at 2 and over, and then times it by 20, because 2 times 20 gets you 40. Or the easiest one to use would actually be the first one that you plotted, that 8 kilometres gets you 5 miles, because at least that's an easy number to work with. So if 8 kilometres gets you 5 miles on the graph, then 40 kilometres would be 5 times that, because 8 times 5 would get you 40. So take the 5 miles and times it by 5 would get you 25 miles. So 40 kilometres is the same as 25 miles. That's not the only way to work it out, but it's the easiest way to work it out for the numbers on this graph. So that's conversion graphs then. The next one that I want to look at are travel graphs, and they are just graphs that show a journey. So this is the distance time graph, shows the journey of a train between 2 stations, and the stations are 6 kilometres apart. So this is the train travelling, stopping, travelling. And the steeper the line, the faster it's going. So during the journey, the train stopped at a signal. For how long was the train stopped? So just look at the length of time that the graph went just going straight across. So that was at 4 minutes, and then the train took off again at 6 minutes. So from 4 minutes up to 6 minutes means that the train actually stopped for 2 minutes. So the train was stopped for 2 minutes. Part B, what was the average speed of the train for the whole journey? So the average speed for the whole journey means it's okay for you to include this bit when it stopped, because they just want a rough average speed. Give your answer in kilometres per hour. So the problem here is that this time is in minutes, so we'll work that out when we come to it. So the average speed, you can use your speed, distance, time triangle. So speed, distance, time, and your speed is the distance divided by the time. So speed equals distance divided by time. And the distance for the train, it went 6 kilometres, and the time it took was 10 minutes. So 6 kilometres divided by 10 minutes. So 6 divided by 10 would get you 0.6, but the distance was in kilometres and the time was in minutes. So that was kilometres per minute, but they want kilometres per hour. So if that's how far you would go in a minute, then just times that by 60. Just doing that in the calculator, so just the 0.6 times that by 60, and that will tell you how far they go in an hour. So that would be 36 kilometres per hour. The other way that you could do it, if you didn't have a calculator and you don't like that triangle, is just to use a wee bit of common sense. So speed is always how far they get in a certain time. So this graph showed that it took 10 minutes for them to go 6 kilometres. So 6 kilometres in a minute, and they want speed in kilometres per hour. So that's how far they go in a minute. Oh no, sorry, that wasn't in a minute. That journey time was 10 minutes. Because it was 10 minutes on the graph along the bottom. So that's 6 kilometres in 10 minutes. And for you to get the speed in kilometres per hour then, to get from 10 minutes up to an hour, you would times by 6, because 10 times 6 would get you 60 minutes, and that's how many minutes there are in an hour. So then take the 6 kilometres and times it by 6. So that's 36 kilometres in 1 hour. So that's a speed of 36 kilometres per hour, and you end up with the same answer as what we did here. So it's entirely up to you whether you want to use the triangle, but you just need to be careful what way your units work out. The way this was kilometres per minute and we wanted it in kilometres per hour. So sometimes using this method here might be a lot easier. So the next type of graph that we're looking at is a straight line graph. So normally for these, they will give you an equation just connecting up the x coordinate and the y coordinate. So complete this table of values for y equals 2x minus 1. So that means the y coordinate is equal to 2 times the x coordinate, take away 1. So they've got 2 spaces here that need filled in. So x is equal to 0, so put a 0 in there. And do 2 times 0, take away 1. So 2 times 0 gets you 0, take away 1 gets you minus 1. Then put x equal to 2 and get the corresponding y coordinate then. So put a 2 in there. So do 2 times 2 is 4, take away 1 gets you 3 in that space. This table is just your coordinates, or these are just your coordinates. So this point here, x is minus 1, y is minus 3. So that's just the coordinate minus 1, minus 3. So go to where x is minus 1 and to where y is minus 3 and plot that point. Your next point then is 0, minus 1. So that's 0, minus 1. So go to where x is 0 and go to minus 1 and plot that point. Next point then, 1 and 1. So 1, 1. Go across 1 and then up 1. Remember, you always go across first. Then 2, 3. Go across to 2 and up to 3. And then the last point, 3, 5. So x is 3, y is 5. So go across to 3 and then up to 5. So once you get your graph like this, that will get you nearly all the marks, but the last thing that you've got to do is actually join all of your points up to make a proper straight line graph. So it had said on the grid, draw the graph of y equals 2x minus 1 for the values of x from minus 1 to plus 3. The minus 1 to plus 3 bit just means that those are the numbers in the table and those are the numbers along your x-axis as well. Then there's another wee bit to this question. Find the coordinates where the line y equals 2x minus 1, that's the slanty line that we've just drawn, crosses the line y equals minus 2. So you need to know where this line y equals minus 2 is. So you go to your y-axis, you go to the number minus 2, and you do a line cutting through that. So that would be, that line there would be the line y equals minus 2. So yes, it's sitting across the way your x-axis is, but that doesn't mean that it's called x equals something. It's called y equals minus 2 because that's the axis that it's cutting through. It's not even actually touching your x-axis at all. So this line is the line x equals minus 2. So the point that they're looking for there then is the point where the slanty line meets the straight line. So we're wanting the coordinates of that point there. So the x coordinate, it is minus, that would be 0.2, 0.4, 0.6, 0.8 and then minus 1. So that's minus 0.4 there. And then down to, so minus 0.4. And then it's going down to minus 2. So you just need to read off the coordinates off, didn't make that very clear there maybe, you're reading off the coordinates off that point there. Right, the last graph is a curved graph, so it's following the same idea as the last one, except your curved graphs will always have squares in them. If they have a cubed, it means that there's just a double curve in them. But at foundation tier, they don't normally go above squares. So complete the table for the quadratic equation y equals x squared plus 2x for x values from minus 4 to 3. So minus 4 to 3 on the table, and then minus 4 up to 3 on the graph is as far as you're looking to go. So again, they've given you 2 here for you to fill in. So whenever x is minus 3, substitute in a minus 3 in there. So do minus 3 squared plus 2 times minus 3, and that will get you the corresponding y value. So minus 3 squared. So minus 3 squared plus 2 times minus 3. So I'm using brackets here just to separate the minus 3 out. So minus 3 squared plus 2 times minus 3. Minus 3 squared means minus 3 times minus 3. So a negative times a negative gets you a positive, and 3 times 3 gets you 9. Just be careful if you're doing negative 3 squared on your calculator. So if you do a negative or just a minus sign, 3 squared, that will tell you that the answer is negative 9. That's because what your calculator is doing is just squaring the 3 and then sticking the negative sign in front. For your calculator to square negative numbers properly, you need to put the negative number in a bracket and then square it, and that will get you the right answer. So just if you were allowed a calculator here, you would put negative 3 squared plus 2 times negative 3. And that will get you 3 for your answer. So we'll see in a wee minute, do we get 3 without the calculator okay? So we already got the first bit okay. And then plus 2 times negative 3. 2 times negative 3 gets you negative 6. And then you've got a plus and a negative. And whenever you've got two signs beside each other like that, the negative is the one that wins, so it stays and the plus goes. 9 take away 6 would get you 3. So that is what we had on the calculator there a few minutes ago. So at the other end of the table then, whenever x is equal to 3, we want to work out the corresponding y value. So put a 3 in there and a 3 in there. So do 3 squared plus 2 times 3. 3 squared is 9, 2 3s are 6, add them together, 15. So a whole lot easier whenever you don't have that minus knocking about making everything complicated. So use the table to complete the graph. So again, these are just your coordinates. So go to negative 2, across to negative 4 and up to 8. So across to negative 4 and up to 8. The next point is across to negative 3 and up to 3. So across to negative 3 and up to 3 would be exactly halfway between the 2 and the 4. So that would be there. Then across to negative 2 and up to 0. So negative 2 and then don't go up any. The next point is negative 1, negative 1. So across to negative 1 and then down to negative 1 would be exactly halfway between the 0 and the 2. So you're having to go halfway down that line. Then 0, 0 is the next point, so that should be an easy one. Just go to 0, 0. Then 1, 3, go across to 1 and up to 3. Then 2, 8 and 3, 15. So 2, 8 and 3, 15. And then this time you can see that you're not going to get a straight line, so don't join them up with a ruler, just join it up with a curve as best you can, just a freehand curve. So go down to the bottom and then curve it and then back up. And just do a freehand curve as best you can without using a ruler. And you'll notice here there's some symmetry from the bottom. Those two are at the same level, those two are at the same level, those two are at the same level. And if we had plotted a point, another point up here, it would have matched with that one as well. But we didn't want this point, it wasn't in the table. Use the graph to find the value of y whenever x is equal to 1.5. So you need to know where the line x equals 1.5 is. So go to x, go to 1.5, so halfway between the 1 and the 2, so that would be that line there. So that's the line x equals 1.5, and we want to know the value of y, so they're not wanting the whole coordinate, they just want the value of y whenever x is 1.5. So go up from 1.5, that's quite hard to see there, so you go up from 1.5 and over. So it's working out exactly halfway between the 4 and the 6 there. So it is working out at 5. So y is equal to 5 whenever x is 1.5. Okay, that's the end of just those few questions on different types of graphs.